Okay, well, thank you, and thank you for your warm welcome, and thank you for the invitation to speak this evening. I'm very honoured to be invited to speak about London Gateway, and hopefully I can be up to meet the expectations of the previous speakers. Yeah, London Gateway, as mentioned, has been my life for the last 14 years. It's been a very hectic 14 years, but something I've thoroughly enjoyed. I know from for the students who are here today, London Gateway has shown many of the engineering people who've worked at London Gateway, from junior engineers, what you can achieve in a port. Ports are sometimes are forgotten about. Everyone goes through an airport, but or actual ports and container ports I'm going to talk about are not something that is very common and most people are aware of. So DP World, just in case you're not aware who DP World is, if you follow the golf, you may know DP World because we tour the race to Dubai, but we have nothing to do with golf actually. But anyway, we are a global port operator. So again, many of you will not be aware of this, but we run over 70 ports all around the world, moving trade. That's our industry, and that is one of the biggest. We're one of the top three global operators of ports and container terminals around the globe. And DP World in the UK, we have two facilities. We have DP World London Gateway and Logistics Park, which is just east of here in Essex. And we also run a facility in Southampton, which is a picture there, is DP World Southampton. So you may wonder, what is a container port? And so many of you have probably been to a port, but not a container port. You may have been to Dover on a ferry. You may have been to Southampton on a nice cruise ship. But pretty rare for you to go to a container port. But they are fascinating, and from an engineering point of view. Some of you may wonder, how do the products that you buy in the shop arrive there? Fruit, TVs, shoes, beef, toys, Ferraris, you name it. You always wonder, how do they actually get in the shop? You know, everyone just goes and orders on Amazon, or they go to M&S or whatever. You go along, but how do they actually get in the country? Because obviously very little is actually made in the UK. So how does it get here? A steel box. So this is the magical steel box called container. So this is one of the three Japanese shipping lines who actually merged last year, and they called Ocean Network Express, not one. They get offended if you call themselves one, but obviously, and their magenta box, not their pink box. But Ocean Network Express, this is a standard 40-foot ISO container. And you wonder how many of these containers are around the world to move trade. So this, and where are they handled? So this is London Gateway, and I'll come on to that in the future, but obviously you see there's a lot of steel boxes is handled and stored at London Gateway as part of the operation. But the container industry is very important, and it's forgotten. You may, next time if you're going home tonight or something, you see a steel container on the road, you know what it's for now. There's over 20 million containers in the world in circulation. 75% of the world's trade is moved in containers. You wonder, how do all those shoes, how does all that fruit get to the UK? All in containers. So you have normal dry containers, refrigerated containers. We handle outer gauge, so we handle all sorts of yachts, boats, parts of aircrafts, all sorts of things. The standard size of containers that you have are 45-foot, 40-foot and 20-foot, obviously originating from the American, actually I'll get in trouble, English have foot as well and things like that. In Australia we don't have that. So we talk metres and centimetres. But anything can go in a container, cars, fruit, clothes, etc. So that is the container industry, all moved around the world. And that's how all the products that should go in the store come from. So this here is a map of London Gateway, where all of our shipping services come from. So you have South America. So nearly every banana that you eat comes from South America. So bananas are picked in the fields of, for example, Ecuador. We have a new port under construction in Ecuador. They are picked from the plantations, solid. They are green, solid bananas, put in a refrigerated container, shipped across the seas to London Gateway. They're then taken up to a factory near Luton, where they are ripened over a period of 6 days. So they come in solid, hard banana. In 6 days, they're ripened, and they're in the store in Tesco, Sainsbury's the next day. So that's, for example, South America. All the wines come from, for example, South Africa, the meats from Brazil. A lot of components for Honda at Swindon come from North America, so you have all the trades from North America come across. And obviously, a lot of other trade comes from Europe and Asia. You know, Asia is the majority of where trade comes from. So 70% of the products in the UK consumed come from China. And that is obviously the main trade lane that obviously has millions and millions of containers come each year into Europe. And how do they come? So this is a container vessel. So this is the Al Zubarah, which is a United Arab Shipping Line container. This has just over 19,000 containers on it. So the ships, that's one of them. The next one I'll show you a picture of. This is another ship coming to London Gateway a few weeks ago. This is the MOL Truth. This was the biggest in the world up until about 6 months ago. So those ships, as I said, they're 400 metres long, 60 metres wide. You've got 4 football fields, end on end, bringing containers all around the world. And some of you may have seen in the news just after Christmas, one of these ships lost a whole lot of boxes in the English Channel, and on the beaches of the Netherlands you had sand shoes, trainers, and all sorts of stuff, because all of these containers are full of products. You may remember on the south coast of England a few years ago, all these guys getting motorbikes and wheeling them up the beach that had come with the containers. You know, these guys have ships have everything, but they are massive. You know, we're talking 200,000 ton deadweight vessels that are bringing the cargo into the UK. So, you have to have equipment and facilities able to handle that. They're very large vessels. So why build a new port near London? And why do we need a new port near London when we already got container ports in the UK? We have a port in Southampton. There's another port up in Felixstowe. But why do you need to build a port? And one of the reasons is that the shipping and container industry continues to change and grow every year, and we need facilities that can handle these vessels. So you think of the airline industry. It used to be 737, 727, whatever, and now they're up to A380. Now you have these ships, and I'll show you shortly, the growth of ships is getting bigger and bigger, and you have to have a facility that can handle such a product. They need, you have a massive influx of containers now bringing trade in, and you must have the ability to deal with it. And you must also have a supply chain. And you may hear about in the industry, supply chain. That is so important to the industry. And we have a very big logistics park at London Gateway, and actually one of my colleagues is here tonight. So a port is more than just a container port. You must have the supporting infrastructure to also handle what happens when all these containers come off. What do you do with them? Obviously, new ports, more sustainable mode of operation. Haulage is becoming a big difficult issue in the industry. So there is a significant lack of haulage in the UK and now feeding into Europe. So you will see advertisements everywhere you drive. HGV driver, we want you, we want you. There is the hauliers are not interested in the UK anymore, or even Western Europe. They're all going back to Eastern Europe. They get more money doing other things. It's a difficult industry. So haulage is important, which means you must have an efficient supply chain, which means efficient ports, efficient logistics hubs near the centre of consumption. And we, as end users, are all driving that. So this is what ports used to look like. Anyone know where that is? City Airport. So that is City Airport. That's the main runway in the middle there, and that was in the 19th century. 1920s, London was the biggest port in the world. Went to containerisation. It moved out to Tilbury, and then further put field to Felixstowe and Southampton. So London used to be the biggest port in the world, and over time it's completely disintegrated, and the port industry. And that's what we're doing at London Gateway, is bringing that back towards London and the southeast of UK. I talk about vessels. So this is how the generation of vessels. So you'll see way back in 1968, the Encounter Bay, you have what we call TU. That's the industry standard is called 20-foot equivalent unit. And over time, the ships, and as you see, get bigger and bigger, and there's no stopping. So the airline industry got to the A380, and a lot of people are actually going back the other way now. But in ships, they just keep getting bigger and bigger, driven by cost. The more you can fit in one ship, the cheaper it is to get from Asia, and therefore it's cost. So you'll see 2018, the ship that we showed you, I showed you two pictures. One was about 19,000, and the other one was just over 20,000. There are new ships due to be launched this year of 23,000 containers. So how do you handle such a volume of containers coming into the country? And again, it's key is being close to the consumer market. So most of the consumption in the UK is around London and the southeast. At the moment, prior to London Gateway, what happened was a lot of the imports were through Felixstowe, Southampton. They get to up to the M1, what we call the Golden Triangle, is in the industry known as. You'll see a lot of, if you've got the big M1, you'll see massive sheds all over the place. They all get to there, and then they're brought back by truck, mostly back down here. There's no sense in that. A lot of additional mileage, wasted time. We obviously are trying to change that model and are changing that model in terms of making the supply chain more efficient. I'll talk about automation. So everyone goes, automation. I always ask everyone, and obviously have discussions with our union on issues like this. What is automation? Can someone tell me what automation is? Is it actually about removing people and saving money? Is it just moving jobs from one skill to another? Does it make the jobs easier? Is it making jobs safer? Is there benefits to the worker? So reasons for automation. One is a lack of labour. Not so much a problem in the UK, but I know we have ports in Antwerp and Rotterdam. They don't have people who want to work in the ports anymore. Young people, why would you want to go work driving big heavy plant in the rain? It's horrible. I just want to sit in an office and do something nice. So automation is one of the reasons. There is a lack of labour. Safety, automated facilities are much safer. That you can't deny that, and there's a lot of safety mechanisms. Less maintenance. We know from, we compare and benchmark against all of our terminals in the world, repair and maintenance for facilities, and automated facilities are less maintenance needy. Productivity, it is required, and I'll talk about that shortly. Weather resilience, and then digital messaging. So the whole of this, you can imagine your box coming from China, it's got trainers, and everyone wants to know everything. You order something on Amazon, I want to know when it's being delivered, blah, blah, blah. So in this whole container industry now, everything is tracked all the way everywhere, when it's discharged off the ship, when it's gone the truck, when it's going to the warehouse. So we can provide information to the end users so they know when their product is. And that's very important because a lot of products these days are just in time. So for example, I'll tell you about the clothing industry. So we have some dealings with some people with clothing industry. The actual ship from China clothing, and by the time it gets here, the fashion would have changed. So they alter them at this end and then put them in the shops. That is, that is part of the supply chain that you have to deal with. So automation, you said these large vessels, got 20,000 containers. You can have 10,000 containers come on or off in one port. You have a mass influx of boxes, and you must have, which can lead to major congestion if you don't handle it properly. So you need a lot of systems and automation to be able to deal with that. Someone asked me earlier, how do you know which is in which box? It's a very sophisticated computer system, but we know exactly where every single box is, where every single box is supposed to go on the ship, where it comes off the ship, because obviously all the ships are stowed according to weight, ballast, etc. Automation is also able to deal with a lot more wind and weather conditions that other facilities aren't. So I talk about a lot of jargon here, ASCs, automatic stacking cranes. We have them designed to deal in high winds. So the last week or so when we had quite significant winds, we did not shut at all. Other ports did shut. There's a whole different safety mechanisms. We're able to deliver the ports and that. And I've talked about other terminals in Europe. Automating the supply chain. So as you come through the port, it's fully automated in terms of gates. Anyone who wants to come and pick a box up has to book online. You have we call a vehicle booking system. You book online, you have your slot, you turn up, You turn up at the gate, automatic or number plate recognition confirms you're the right truck, you've got the right box, tells you where to go to in the stacking area. Fully automated, no paper, and that is part of the efficient supply chain. So London Gateway, and I'll talk about 25 miles east of here. So some of you may know Essex, you may have heard of the Sugar Hut or some of those places, a bit south of those in Essex. And this is a deep sea container port and logistics park. So you'll see the logistics park in the front and obviously the port in the background. So it's over 220 acres for deep sea container port, and then the logistics facility has over 9.25 million square feet of shed able to be developed. And I talked about the logistics park. Yeah, that is a key part of what London Gateway is doing in terms of supply chain. Here you can see here we have UPS, one of obviously the US. This is one of the US's biggest, largest investments outside the states, doing parcel delivery. Dixon's Carphone Group, Lidl, CMA is a big shipping line with all frozen and fruit products. Pratt's, you probably never heard of them. They're the biggest importer of bananas in the UK. Nearly every banana you probably eat comes through these guys' facilities. And obviously more and more are being developed at the moment. All part of the supply chain. For example, if you have a refrigerator good, so for example, Pratt's or CMA will have cold stores, etc. If they can save 1 or 2 days on the supply chain, that is worth enormous amount of money to them. It gets into the shops quicker, and therefore the shelf life is extended. Okay, UPS I've talked about again, fully automated facility for parceling up to 28,000 packages in an hour. You know, these guys are delivering all Amazon stuff and all sorts of things like that. And they bring a lot of European cargo in from in France and Belgium and is distributed into the UK out of London Gateway. So the terminal layout and what London Gateway is, I won't go as it's the only engineering drawing I'll show you, I promise. So we have here, this is this is the whole port area. We have a key structure here, container stacking area here, so it's all the containers are stacked. And then we've got a rail terminal at the back here, then gate, and then you've got the whole park behind it. This is just a cross section through the facility. So a big ship, a big key crane, which unloads containers on and off the vessel. We have little machines here called shuttle carriers, which a lot of people think they're from Star Wars, but they're not. They take them to automatic stacking crane, completely manless crane, picks it up, stores it in the yard, and then waits for a truck to come pick it up at the other end. But I'll show you in more detail as we go through. Now, I do have a lot of slides and pictures on the engineering construction, but I won't go in too much detail on that. I'll just flick through them to show you what we've done. But I think the key thing for me, some pictures here, is 1.5 billion of capex was delivered on time time and budget with no public money. Very important point here, because we are competing against ports elsewhere in Europe which are publicly funded, and that makes it very difficult for the UK to compete. So, very important point. So how was it done? This was the refinery in 2000. So it was a big oil refinery, which was obviously went through a public inquiry, and I joined just at the end of the public inquiry. It then took us 5 years and £50 million later to get approval. Again, for an overseas investor, you know, our parent company is based in Dubai. It's a lot of risk for people to put a lot of money in privately to invest in facilities like that. And the UK, obviously, it needs to be conscious of that. 5 years and 50 million, if they could have said no, that would have been the end of the project. And then work commenced in 2009. So again, day zero, this is what the refinery used to look like. It was then demolished, and obviously that is prior to remediation. So this was the old Shell oil refinery in Corrigan. Obviously, I was talking to someone earlier, there's a bitumen plant here. So that's the old bitumen plant which was there when I first started on site. That was one of the only operating facility there. Aviation fuel is actually this one here. So aviation fuel, if you fly out of Stansted, Heathrow, etc., that fuel comes through London Gateway. So it actually comes at the end of our facility. We have an aviation import facility. It's then taken by pipeline all the way around the UK, military bases, Buncefield, and those sorts of places. Key works, and this could go on forever and ever, but some of the key things, we did 30 million cubic metres of dredging in over 100 kilometres, 1.25 kilometres of quay wall, ground improvement, and I'll go through this in detail, rail terminals, remediation, a lot of animal clearance, a lot of buildings, and we'll go through that in detail. So I'll quickly go through some of the works. Archaeology, okay, pretty standard these days, archaeology. Some of the things we found. Archaeology in the river, it's a bit different. So one of the things you have to tell people working in the marine field is different. So some of the things we found, this is a German aircraft which was in the dredging. We actually had a body in it. So we had dealings with the German embassy and was tracked back, so that the person was tracked back and was dealt with sensitively. HMS London, this is everyone knows about some of the historic Mary Rose and things like that. This is a 16th century timber vessel, HMS London, which was in the Thames, we discovered during our investigation work. So we had to alter the channel and obviously make sure the dredging could cater for aspects such as it. Again, there's a whole lot of wrecks we have to deal with. This was a light vessel for navigation, which was bombed in the Second World War II, and you can obviously see it on the seabed. Environmental. London Gateway actually created a few challenges for people like Natural England. This was Europe's largest ever ecological program. We moved over 350,000 animals off the site. The question is, what do you do with 350,000 animals? Very difficult. So we created a whole lot of newt ponds on site. We took lizards and snakes to all these disused airfields all over the country, water voles, all sorts of things. But it's quite a challenge to deal with that amount of animals, and it was a good learning for a lot of people involved. There's some of the newt fences collected. We had for 2 or 3 years in the summer 100 students coming and picking newts, lizards, snakes, all sorts of things, and then obviously house them to different parts of the country. A lot of, because of the reclamation and creating the port, we destroyed, covered up mud flats, so we had to create new mud flats. So these are a couple of mud flats. This is on the Essex side of the river, and this is on the Kent side of the river. So we built a new flood wall around the back, and on both of them the new flood walls were around the back. These are old farms, and then we breached the current flood wall to create a new mud flat for birds to feed on. And I know this one here had a requirement, it must feed 7,600 and something birds, etc. But they are very, obviously wildlife has enjoyed them, and it's nourishing in these new mud flats that we created. And obviously sustainable construction. We imported for construction a lot of the aggregates through on bulk vessel. This is a Yeoman Aggregate Industries vessel bringing in material from Glen Sander in Scotland. Dredge and reclamation. So we dredged for the deep, got these new deep drafted vessels. So you have to obviously have the channel deep enough to bring these vessels in. So we dredged nearly 100 kilometres of channel and reclaiming the port in red. So we reclaimed 100 hectares out of the river Thames. This is a dredger. If you're not sure, I call it a floating vacuum cleaner. So all it is goes along and sucks up the seabed. The material goes into a hopper in here, and then then obviously the water is displaced. You will see a plume out the background, and I'll come on to that. This is a fact of dredging that obviously you have to deal with. This is the importation of dredge material for creating the port. Everyone thinks the Thames is horrible and muddy. It's actually beautiful sand and gravel, and great material. So this is all sand and gravel. If you go along the Thames and you get that horrible muddy water, pick a glass up. Within 1 minute, all the silt's gone to the bottom, crystal clear water. So it's just the sediments in suspension that are going up and down with the high tide rate that causes that effect on the river. But it's a very clean river. A lot of fish here. We compensated the fishermen for the disruption due to dredging, but all the fishermen were actually following the dredger very closely to get their fish. And we compensated based on declared fish. So what do you reckon happened in the preceding years till we started dredging? The declared fish went up enormously. Okay, so then you see here there's the creation of the port. A lot of environmentally modelling was carried out. This is creating the port out of the Thames. This is phase one. And then there's a process here from that one there to there, to there, to the end of reclaiming the port. So I said we reclaimed 100 hectares, 30 million cubic metres of sand and gravel was brought here to create the port. Unfortunately, you do come across a few other things. So you have a UXO. So you're obviously in the drag head of the dredger, UXO. This is a 2,000 pound parachute mine that we caught up as part of the dredging. And a funny story, we had our own detonation people on board the dredgers. Obviously the Navy aren't too, they got other priorities. But we found this 2,000 pound parachute mine wrapped around the dredge. We didn't want to touch that one. So we bought the Navy out. And this is the day two. The first day they came and picked it up, put it on a pontoon next to the dredge, left, they said it's getting dark, we'll come back in the morning. Gone. Fell off. So they then went around the coast of Essex and they eventually found it again, not far away, and then they detonated it. True story. Obviously we're dredging, very sensitive. We have a very extensive marine monitoring system, and so this was a real-time marine monitoring system that we had in place. And this system has actually been adopted in a lot of places around the world now. So we had our consultant, HR Wallingford, doing a lot of work for us. Subsequent to this, I know this has been used in some sensitive projects in Australia where I come from with dredging. This is 100% real-time monitoring. We have buoys all along the river measuring suspended sediment concentration, dissolved oxygen, currents, everything. So as the dredging is going on, if for some reason the levels of dissolved oxygen drop too much or the suspended sediments got too high, we would stop the dredging, move the dredging. It's all real time, but it was very well, and we've had no impact at all on the cockle fishermen or some of the fishermen in the Thames, which is obviously very important. Ground improvement, traditional ground improvement, band drains, we installed enough of them to go around the world. Quay wall construction, we had diaphragm wall construction. It was built overfilling. We actually overfilled and then built the diaphragm wall, the front one and the rear one in the dry. So you've got the front wall here, 1.5 metres thick, and the rear one a metre thick. And this is, you'll see after the material has this is after the quay wall is built. So you'll see at the end here, this is how we built it. We overfilled with dredge material, and then the quay wall was built, and then we came along at the end and excavated the material out from front. The front diaphragm wall is 50 metres deep. It's a very deep diaphragm wall, 1.5 metre, 28 metres unsuspended from top to bottom, because obviously you got the dredge pocket is -17 chart datum, it was +10 at the top, so it's 28 metres of unsuspended to the seabed. And obviously this is quite low down. You'll see a lot of tie rods. They were diameter 100 at 1 metre centres, holding the two diaphragm walls together. Did a lot of highways works as part of the, and this is where it's difficult to convince investors and banks. We spent over £100 million on highways works, which we don't own. So that is difficult to convince a bank to give me £100 million when it's not their own infrastructure. So we did a lot of work on the A13. So this is the A13. We had to completely rebuild a junction to there. M25, we had to do some work on a slip road. We had a new access road into the port, so this is when the stripping had been done for checking archaeological conditions. Obviously a new road being built. Railways, we built 25 kilometres of P-way for the rail terminal, including connection to the branch line. So we've got the automated track laying machine here. Connection to the branch line, taking the trains away from the houses. The old track which came to the refinery is up here. We've twin tracked it, bringing it away from the houses, obviously for noise mitigation. And there's the siding construction underway. And then obviously the rail terminal as it is today. We have 60 services a week, including we do have services to Europe and to China. The China one is currently not under operation, but we have had trains all the way from China. Buildings, okay, just some of the pretty pictures of buildings, workshops. Someone said don't mention Brexit, but this is where all the goods come through and authorities inspect it. If there's a problem after Brexit, it'll be in here. But we're okay, we're not concerned by that. but a lot of discussions with the authorities. So all meats and fruits that come into the country are inspected, they're outturned, they check for diseases, qualities. You know, at the moment, 100% of chicken coming from Brazil is inspected because there's some strange things going on in Brazil. I won't go into the detail, but people are approving products they shouldn't be. So there's a UK requirement that 100% every container that comes in with chicken from Brazil, and that could be in Nando's or wherever it goes, is checked here. So it's a very intensive operation. So then how do you operate the port? So you've got equipment, so you've got key cranes. So these are very large steel structures. How large? Boomed up, they're higher than the London Eye. You'll see this is where the driver is up here. It's 50 metres off the deck. These container ships, obviously 25 wide, boom, 138 metres up. Very large structures that the driver has to take containers on and off. You see how high they are? This was taken last week. So it was a bit foggy one morning, but nice picture that one of our drivers took. And what we have at London Gateway is a unique ability to take off a lot of new modern and automation. So traditionally you get one box off at a time. We've actually got cranes that take 2 boxes off at a time and sometimes 4 boxes off at a time. So that is key to the product that we have. So it's a very sophisticated crane to deal with that. And you know, these cranes, and we're talking about automation, you could drive these cranes from Australia if you wanted to. So they're all remote, they're capable of being remote driven. So they have 16 cameras on them, and you could actually be in Australia and driving this crane if you wanted to. So, and this is where automation is helping out, because drivers, if you're up in this crane, you're looking between your legs down the ship, you don't see much anyway, so you may as well be in an office driving it in a nice, comfortable condition. And that's why automation is key. Very sophisticated sway systems, optimum path control, crane OCR, you may not wear this. We have on what we call optical character recognition. So every time a container comes on or off, it takes an image and does character recognition, because every container has like a barcode. And that's part of all the messaging throughout the whole of the industry. So we know exactly where that container goes, and it goes to all our different equipment automatically. There's no piece of paper with any of our drivers have to follow. They're all following messages on their VMTs and screens, etc. And the driver actually doesn't drive much of the crane anyway. Most of the crane cycle is automated by a computer system. The only bit that you cannot automate is going into the ship. Unfortunately, the automation, the scanning software that's around, and the scanning technology is not reliable enough to go into the ship. Other than that, everything else is scanned. You can go and have a box behind the crane we pick up. The crane will scan it from 50 metres up, crane will go down, land up, off it goes. But going into the ship is a challenge which it will be overcome. So this is the tandem operation. You have 2 containers at one time. We're the only one in the UK that do it. How do you get them here? These are made in China. So you actually bring them on a ship, fully erect. So there's a factory in just off Shanghai. If you ever fly into Shanghai, about a minute before you land, look out, depending which side you're flying in from, but anyway, there's Changxing Island. They manufacture 70% of these cranes. These are 2,500 tonne cranes, and they have their own modified oil tankers, and they ship these all around the world. They do occasionally lose some, but generally not. And when you're insuring, we make sure our deliveries are separated, but they're all shipped in crane. And then you'll see the delivery. The question is, how do you get them off the ship? Simple. Sorry, that's the last engineering drawing. Simple pulley system. So you have 2 containers full of water, ballast. You then have a series of pulleys, wire ropes around pulleys, one to the front of the legs and one on the back. Simple pulley system, off they come. I won't go through it today, but if you look on YouTube and you've got the one show, there's that guy, Martin, the science man or whatever. He came to London Gateway and showed you how you do it. But very easy. This crane, 2,500 tonnes, off a ship, onto land, 45 minutes. Simple. Very easy. And obviously the vessel has sophisticated ballasting systems in there. That's the key to it. And again, you'll see the picture here. Coming off, this is on the ship. They've got a bridge here. You'll see all the pulley systems and wire ropes, and back the other way, controlling it, tension, etc. Letting off the slack, pull it off, 45 minutes, done. The yard, fully automated stacking cranes, all run by a computer system. loading of trucks fully automated. So there's no involvement. We have the trucks, the cranes have scanners on them, so they scan the truck where it is, creates a 3D image of the truck, and then loads the container down onto the truck. Very sophisticated, can design and work up to 28 metres a second, very high winds. Again, you'll see this obviously a busy truck interchange, the truck's been loaded on the land side. They're all made in China, come in pieces. How you get between the key crane and the automatic stacking cranes is what we have these Star Wars machines, so they're called shuttle carriers. In London Gateway is a forefront of technology in terms of energy efficient machines. So we have 11 of our hybrid shuttles are hybrid. 11 of our machines are hybrid. Fuel savings 30%. Plus we also are trialling at the moment the first electric shuttle in the world. Now these are big heavy machinery running around, regenerating power by obviously braking and lowering and raising the containers. So the whole port industry is obviously moving that direction. So you'll see the containers being unloaded from the crane, which are then run to the stacking areas. These are made in Poland, fully erect, come in. Fast charge, this is what the system they call. So we completely charge a shuttle carrier in 6 minutes, and it can run around for the next hour, hour and a half, moving containers around. RMGs, this was a nice little challenge. We had 3 fully erect from China. We had to bring across the sand. This was back to a very historical engineering and practical. They only bought 200 metres of rail and we had a kilometre to go. So put timber sleepers down, rail on top, pick it up, move it down, pick it up, move it up. And I remember it was a horrendous, this is a beautiful picture, but the second one we moved was in the rain. But some of the challenges of moving it. And obviously there's a very sophisticated IT system. I won't go into all the details, but the system is very sophisticated. So you have the system that deals all the customs and clearances of boxes, the crane, OCR, this is what we call a system is NAVIS, so actually the terminal operating system, billing system, finance, talks to the automatic stacking cranes over there. I won't go into any more detail and confuse you, but it's a very sophisticated, and obviously in an automated terminal, if the system's down, you're dead. And a very important lesson that a lot of IT automated projects around the world, the requirements for IT are far, need to be enhanced far more than they currently previously were. So resilience is key in that. And then the end result, and nearly finished. And to go through, this is a couple of videos that I have which will show you. So this is on the operation on the water side. You'll see obviously the key crane puts the box behind it, and then the shuttle carriers pick it up and then put it into the stacking cranes. That's frozen. Yeah. One of the things you'll notice, it's automated. The stacking area is dark. What do you need lights for? So you'll see it goes completely black. There's no point having lights. Good for light, reducing light pollution. No point wasting electricity and causing light pollution. And then we'll go to the automatic stacking cranes on the land side. Now these truck drivers like that, they're going to have a chat to each other as the boxes are loaded on and off. And this is key in terms of the productivity, turning containers around quickly. We have the best truck turnaround time in the UK. We're able to efficiently handle containers on and off the facility because of the automated nature that we have. And there's obviously enormous amount of safety systems in here, which obviously I won't go into, but it's a very safe system. And in conclusion, I will just show a bit of a video.
We love moving things efficiently, reliably, safely, on a scale that's quite simply immense. With our unrivaled proximity to the UK's largest consumer markets, with the most advanced and best connected logistics hub in the UK. DP World London Gateway is a state-of-the-art deep-sea container terminal on the same site as one of Europe's largest logistics parks. Automated systems, future-proof technology, and a strong focus on sustainable operations mean we can make your supply chain faster, more reliable, and more flexible. DP World London Gateway can accommodate the world's largest ships and handle the millions of products they transport. To achieve this, you have to think big, really big. That's why we have the biggest quay cranes and a unique ability to handle more of the largest container ships than anywhere else in the UK. The cranes are capable of turning around these giant vessels faster and more reliably. We currently have 3 deep water berths and potential for 3 more. And with a deep water channel that gives us the biggest tidal window in the UK, we can handle these ships with less fuss and more speed. Your goods are then moved to our fully automated, weather-resilient stacking system. We're almost never closed because of adverse weather. Our online systems make it effortless to book vehicle slots and track cargo. With an automated loading system and dedicated landside stacking cranes, there's no waiting or delay for hauliers. We have huge capacity if you want to move your goods by rail to any major UK destination. This investment, technology and automation combines powerfully with our on-site logistics park and team of experts. All this in turn gives endless opportunities to enhance the speed, efficiency and reliability of your supply chain operations. So yes, we've been thinking big. It's all part of our constant effort to improve every aspect of our performance and make a real difference in enabling our customers to deliver for their customers. Accelerating trade, delivering growth, securing success. DP World, London Gateway.
So in conclusion, DP World, obviously a very important and very exciting engineering project. We in our peak had nearly 4,000 workers on site. We're currently, for the last 3 years in a row, being the top 5 growing ports in the world. Annual growth apparently currently around 30%. The logistics park, which is obviously a key part of London Gateway, is growing at a record pace with, we think, probably around 1 million square foot of shed space will be open under construction this year. And the future of the UK supply chain is only 25 miles east of here. And as I said, we've only just started. In terms of the port, we've only built about 40% of it. And the park, we've only built about 10 to 15%. So this is a large infrastructure project which will be going for many years to come. So thank you very much for letting me speak to you about it.